Okay, so don't you guys see my screen? Not yet? Okay. How about now? Okay, that's strange. And how about now? Okay. So looks like one of the ISP has problem and the other one is working fine. Okay, so I guess everyone is good, right? Okay, so guys, the topic for today is the lab. Of course, the lab that we were doing in the previous weekend or the previous week, BGP path manipulation. So this class would be continuation of that lab. I'm going to show you the lab setup and how you guys need to do this. Okay, so someone who have not done during the weekends. Okay, and yes, after completion of the lab I'll be covering up few more attributes which is other than these four attributes that we are discussing. Okay, so just a quick briefing. So we are focusing on the four attributes. That's are those four attributes that can be changeable or modifiable. Okay, so those are weight, AS path, local preference, and MED. Okay, so these are four out of 11 attributes. The other ones, like the other seven attributes, they are not something that we can change uh, to get a path manipulated or something. Okay, they are present in the path manipulation just to understand the flow of the packet, but they cannot be changed. So if I show you my flow chart once again, so if you see this, so these are few attributes, okay, which can manipulate your BGP path. Okay, the BGP path forwarding, the packet can be manipulated. So we are going to do lab on these four and this. Okay, now if you're wondering why I'm not gonna cover the other one, so basically they are more with the theoretical topics, not something which deals technically. Okay, originate in the sense which is originating from the local router, right? So whenever I'm configuring BGP, it's something which will take it automatically. So you should know from theoretical point of view what are originate, what do you understand by shortest IGP path, or what is EGP over IBGP. So they are theoretical part, they're not technically something which I can configure or manipulate, or I can do something to change the path forwarding. Okay, we discussed about two path forwarding direction. One is inbound direction, or in other way we can also call it as incoming traffic, or outbound traffic, the traffic that is leaving outside of my organization. I can also write it as outgoing traffic. Okay, so these are the main traffic that we normally deal with: traffic which is coming to us and the traffic which is leaving from us, right? So depending upon this, we discussed some attributes. So in previous class I was discussing about outbound traffic, so we did a lab on this weight. Okay, And on later on, I said there is one more attribute that can be also used to manipulate the direction. Okay, so the other one was local preference. While in the case of inbound, the two attributes that can be changed or that can be manipulated are AS path and MED. Okay, so where are these listed? So you can see one of them listed here, number 1, and you have on second number local preference, that's over here. Okay, where is AS path? It's your fourth attribute. Where is your MED, multi-exit discriminator? It's over here. So these are the four main attributes from the changeable or modify type of attributes that we can modify, which are technically deals with the numbers. Okay, whereas rest are all theoretical topics. Like for example, this you need to know what does it mean. See, this is a theoretical topic. Same goes with the oldest path, same goes with this one, and same goes with this. And yes, these are something which is prerequisite to have BGP, right? So it doesn't deal with anything manipulation or something. It's a prerequisite. I must have IP address on my router to have BGP process coming up, right? So these are two uh, prerequisite, whereas the rest of them, few of them are theoretical and few of them are numerical or technical, where you can change the values and impact the flow. Okay, so why do we need to manipulate these flows? I mean, on what circumstances do we need to manipulate, right? So if I show you this lab, okay, so let's say I am the network engineer for this organization. This is my organization. Okay, XYZ. So my traffic, which is directly connected to ISPs. Okay, so I can have users sitting within my enterprise who on daily basis upload a file which is on another data center, or might be they are accessing some email server, or any internet bound application. So basically the routers, these two routers, which are also called as BGP routers or edge router, they need to have the protocol BGP. The BGP is one such protocol which will forward the packet, and also it will receive the prefixes or networks. Okay, so we are tuning BGP so that our packet is preferring the best path. Now what do you mean by best path? Let's say on this way, on the Vodafone way, you had some serial links. Okay, even though they are the primary link, might be their primary link, and they have serial link or serial connection, might be you see there is a lot of packet drops, or eventually the slowness, all those things. So in order to avoid using this as your primary path, you would like to manipulate your path. Okay, so that your path is now preferred over on this direction, AT&T, and then goes to Verizon, and then goes to Google server. So this is all with respective to BGP manipulations. Okay, the way you want to receive, the way you want to send the packet. So we discussed about the first attribute that was called as weight. So to demonstrate weight, I had taken up this diagram. Okay, I said weight is such protocol which is a Cisco proprietary, and it is locally significant, in the sense when you have this kind of network design, one router which is connected with two different routers on the ISP side. So let's say this is a AT&T ISP provider, and this is my enterprise XYZ. I have two connections, something like this, dual home. Okay, so in such scenarios, I can make use of the weight attribute to manipulate my outgoing traffic. Weight is a outgoing attribute, okay, to manipulate the outgoing. So I can manipulate outgoing. I can say to reach AT&T, let's take this instead of this path. Okay, it's a locally significant. Now let's say what happens if I bring one more BGP router. Now the drawback of weight is I cannot make use of weight because they are locally significant. Only a single router is gonna know what is the weight that you have set over on this and over on this. Okay, so wait is not an attribute that will work between the two routers. So that is why we cannot make use of wait when I have multiple BGP routers. And you might be knowing nowadays all standard medium segment to large segment enterprises, they go with uh, multiple redundancy. They will have 2 or 3 routers in their core acting as a backup or redundancy or aggregation, right? So let's say in this design, I have a core router, or let's say behind this core router, I have users placed. Okay. And these are 2 customer and routers. So I have BGP running here. Also, I have BGP running here. And to make it simplified, what I'm doing, I'm just taking a BGP once again on this. Okay. So they are gonna be iBGP. This is gonna be iBGP, and then on the other side they are all ISP. But since this is a home lab setup, I must do the configuration on other side as well, right? Whereas in production we don't have to. The service provider will have their own network engineers who will do the necessary configuration. But as of now, I'm only the one who will do the A to Z configuration. So what I'm running here, I'm running another instance of BGP, which is eBGP. Same goes here. I have eBGP, and over here I have iBGP internally, and I have eBGP in between my destination and the Verizon ISP. So the task here was to manipulate the path. Okay. So what happens is when I have configured all BGPs, all on all the routers, when I open up this router, I will see what is my path, or what is my best path to reach this. That was first observation. Okay, the first observation was to see what is the best path to reach this destination, because you have 2 paths. It can take this way or it could have taken this way, right? So as for from the theoretical topic, I would say that it will take the lowest router ID. Okay, so in this case this is having lowest router ID, so the traffic will take this. But again, it depends on your configuration. Might be if you're having the configuration already powered on, so that will be taken up uh, as a first route. Okay, and then you bring up the second route, so there will be no auto, what do you say, there will be no auto negotiation for that. So you have to manually make use of the clear IP BGP process, so that you want once again them to uh, negotiate or re-elect and then select the one. Okay, so as for from the theoretical topic, BGP is gonna take the lowest router ID, whereas in case of EIGRP and OSPF, they consider the highest router ID. Okay, in the case of BGP, it will say it takes lowest ID. So let's assume, since this is lowest one and we went through with all the configuration at a time, and I powered on all of them at a time, so it's gonna take this by default. Okay, now here is where my task number 1 will get started. I want to make use of local preference configuration to see, uh, the first thing is to configure local preference and see how is the packet moving now. Okay, so I bring local preference. So by default local preference is 100. I'm gonna increase by 50, or I am going to increase it to 150 or something, so that so the higher is preferred. Okay, so I'm gonna make it 150 here, so automatically this path should be taken up. So that was first task. The second task was by seeing the AS path attribute. So in this case, in AS path, which is for incoming traffic, the traffic which is coming inside my organization. Okay, so what I was supposed to do, I was supposed to prepend some AS values, some dummy AS value. Okay, so let's say this was the preferred way. Okay, this is the preferred way. I'm gonna prepend some dummy values, dummy AS values. So eventually they becomes additional 2 AS. So you know, one of the criteria is the shortest AS is preferred. So this gonna be uh, taken out from the routing table, and this route will be put up in the routing table. So that was regards to AS path. And with respect to MED, multi-exit discriminator, so to see the behavior of multi-exit discriminator, the main thing is it's when your single router has two directly connected ISP, two different directly connected ISP. So like for example, this is one ISP which is directly connected, and you have one more cable which is directly connected to ISP2. In such scenarios, you can bring up your med and you can see how the med is going to manipulate. Okay, so these are four attributes you can use the way you want, or the circumstances that you are facing in your organization. Okay, it's not hard written that you must use AS path always or you must use local preference. But I would say for outbound, since weight is a Cisco proprietary, you are left with only local preference. And for inbound, since this is very rare cases that you have a single router with two ISP, so you're only having a good one with AS path where you can achieve lot of manipulation. Okay, so these are two things. But let's see from the lab point of view, and let me show the lab that was supposed to be done, which in case if you're struggle and might be some guys with busy with your work schedule, let me quickly show you what is the configuration and how do we see the behavior. Okay, so I have powered on the devices, and let me walk you through each one of them. So they are just basic BGP configurations and nothing much. So let me take one by one the consoles. Okay, so I have all the nodes being taken up. Okay, so they are forming the BGP neighborship. So first thing what I'll do is I'll try to see if I have a ping reachability from the core router to the destination. Okay, and then I'll show you the configuration. So let's ping first. Okay, so they are coming up. Let it come. Okay, so let me see the other routers if I can read the prefixes. Okay, so I see this. Okay, so they started running now. Okay, so my destination is reachable. On which path is this destination being uh, considered, whether on the AT&T ISP or over on the Vodafone? Those are the two directly connected ISP, right? How can I check? I can check, I can make use of show IP route 8.8.8. So it's gonna show me the best path. It's preferring 12.2. That means it's preferring this path, AT&T path. And that was my assumption also. I told you BGP is gonna prefer the lowest router ID, right? So out of these two, AT&T and Vodafone, by default the behavior would be towards lowest router ID. Okay, so once let me show you. Let me show you one thing. Okay, so if you see this table, I've said, let's assume we have not manipulated any of the attribute. So we are only left with the router ID and neighbor IP address. So who is gonna be preferred? It's your lowest IPs. Okay. So since I just powered on and I don't have any manipulated data, so by default, as per theory, it's my lowest router ID that's getting selected. So that's good. That's something which I can understand. Okay. I can also prove this with the help of trace route. If I do a trace route, so you can see it went towards AT&T. From AT&T, it went towards AT&T. This is the AT&T router. This is the Verizon router. This is one of the other Verizon router, and finally it reached the destination. Okay, so it purely took this path. So where is 12.2? It's this, the first hop. Okay, let me make use of other color. So let's say the first hop. So the first hop was 12.2, that is this interface, and then it went towards 2.2. Now that's nothing but this IP. Okay, so I just write it as AT&T, and then it went to 4.2. 4.2 is nothing but this IP, this interface IP. That's nothing but the Verizon. Okay, and then it went towards 102.2. Now that's the IBGP router. Okay, IBGP router of Verizon. So let me write IBGP of Verizon, and then finally towards 5.2. That's nothing but this network 5.2. Okay, that's the destination. And where is the loopback connected? It's directly onto this. The loopback is directly connected to this. So this is my path that's selected by default. Okay, I can also make use of show IP BGP. Okay, show IP BGP command. So which is gonna show me all the best path. Okay, so the destination has two best path. Okay, but it's gonna prefer one of them, which is AT&T. Okay, so 12.2 is marked as a best path. So this is the best path, even though you have the secondary path. But I don't say that this is a bad path. When you have two routes, BGP is by default gonna take only one. It's not equal load balancing, or it doesn't support unequal load balancing how you have in the dynamic like OSPF or EIGRP. By default, BGP is gonna take only one path. Okay, so that's why you can see only one path. And just to double check, go towards routing table and see the best path that's been placed. So it's over on 12.2, right? So this is your first step to see the packet flow. Now let's see what is the configuration that I have done. Okay, so nothing much. If I show you the BGP configuration, so I'm just having a IBGP. Okay, so one IBGP with respect to the CE2, C1 and CE2. Okay, so I have IBGP relation with these two routers from the core router point of view, and nothing else other than the normal interface IP, which I can also show you. Okay, just one loop back and two physical interface IP. So that's the first configuration. On the second, or let's say the CE1, okay, the customer end first. So over here, let's see what configuration I have for BGP. So for BGP, I will have one eBGP relation. So that should be this. This is towards the core, okay, the IBGP relation. So this, and just discard this one, okay, because I am not gonna use any more IBGP which is not required. Okay, I'm going to remove that. I'm going to remove these two commands which is not required for me. So that was on C1, and yes, as you know, just the interface IPs and nothing much. Okay, the three interfaces. Let's go to the CE2 and let's see what configuration I have on this. Once again, straightforward. One eBGP with Vodafone, the other one with its own iBGP. And yes, the 14 network, I'm going to discard it. It's not required. Okay. It was present in my last class, but now I thought, let me not bring lot many network and just increase overhead on this. Okay. I'm just taking out the 14 network because this is sufficient for me to demonstrate. Okay. So these are the three routers from the enterprise level. Now let's see from the AT&T router. On the AT&T router, it must have two eBGPs, one eBGP with myself, and on the other side, the other eBGP with the Verizon side. So you will have a pretty straightforward configuration. So you have this with me enterprise, and this is with Verizon. Okay. And what about the interface? Once again, the basic interface configurations. Okay. Two physical configuration, IPs configuration. What about on the Vodafone side, which is called as P2, show run session BGP? Straightforward, one on your left side, other one on the right side. On left, you have your enterprise. Okay. And on right, you have your Verizon, the one in a little reddish color. Okay. Fine. Now, what about on the Verizon side? Okay, so on Verizon side, on P3, which is nothing but this. So this is a router. I have just changed the icons. Okay. So over on that router, so you will see this is iBGP. Okay, and you have one more iBGP which I have removed it out. If you remember, there was a iBGP over here which I have removed it off. Okay, so this is not required any longer. So I have one iBGP which is on this side, other one eBGP connection. So that's this one. Okay, on left side eBGP, on right side iBGP, and the basic interface configuration. Let's see P4 which is ISP which is connecting to Vodafone. Show run session BGP. So once again, you will see 104 which is not required. Okay, we can just place no and remove them. Otherwise, we will see this getting advertised in our routing, and we will see a lot of routing, unnecessary routing prefixes in our routing table. Okay, so it's better you place no and take them out, which I'll do in few minutes. Okay. So with respect to this router, I have on my left my Vodafone router. Okay, so this is for Vodafone, and on my left side I have iBGP. Okay, that's between this. What about on P5? P5 is nothing but the uh, edge router which is connecting to the destination. Okay, directly connecting to the destination. Okay, so on P5 you see there is one connection which is iBGP. So it will have one iBGP, second iBGP, and eBGP. Okay, so two iBGP, and there will be one. So this is eBGP with respective to Google server. Okay, over here. And what about on the final router that's acting as a Google server? So over there you have your loopback that's advertised as a network. Okay, and for a neighbor you're making use of this physical IP which is acting as a neighbor. Okay, it's just a single eBGP connection here. There are no dynamic routing or nothing else. So overall there is no dynamic routing protocol, it's only BGP. Okay, fine. So as you know now, what is the direction to reach this server? So if I do show IP route 8.8.8, I see it's going across on 12.2, which is AT&T path. Okay, It's a AT&T path, the topmost ISP. You can also check via trace route 8.8.8. It's gonna show you the complete path, or you can make use of show IP BGP, which is gonna show you the two best path and the one which is preferred. Okay, so this is preferred. So preferred one is, this is the AS path 2, 4 and 5. That's nothing but AS path 2, 4 and 5. Okay, so this is the preferred path. Well, so the task number 1 was to manipulate the change. So let's say, I don't want to place this as a strict rule that always this should be the best path. As I told you previously, it depends upon your configuration and it depends on how you power on the routers. Okay, might be in your case this could be the best path also. So don't think that you have done a wrong configuration. You have done a right configuration. It's that you have configured it first and then you're configuring the second one. The lower router ID might be you're configuring the second time. So that's why in case of BGP, in case of OSPF, in case of EIGRP, there is no auto negotiation or auto election. Okay, so we must manually clear the process so that re-election happen, and as per theoretical it takes the whatever it is. If in case of BGP it is lower which is preferred, right? So in my case I had configured it, and just in front of you I powered them all in one single click, right? So as per theoretical topic it started taking up the lower ID. So that's something which you should remember. If you see in your case this is getting picked up, don't think that, don't waste your time on bringing the other one up. Okay, you're all perfectly right, you just need to manipulate now. Okay, so the task number 1 here is to make use of local preference uh, to manipulate the behavior. Let's say I'm not happy with this path and I want for some reason this path to be preferred. Okay, so yes, the traffic which is going outgoing traffic, we know one is wait which can help me. The second one here was local preference. This is getting taken out. This is getting excluded. The reason is it's locally significant. I have three BGP routers. I cannot make use of this. So only left out is local preference. So let's do that. Okay, let's see how do I change that. So as we know, local preference is something which is highest is preferred, and by default they're gonna be 100. So let me show you the local preference that's been assigned. So you can see by default 100 is been assigned. So I'll go to C2 and I'll increase the local preference value. Okay, so how do I do that? Okay, so you can see on my left side on the green highlighted configuration. So that's a configuration for local preference. It's just a 2 lines. Okay, you go to towards your BGP and say that local BGP default local preference and 150. Fine. Now this doesn't end here. You must clear the process. Now there are two ways to clear the process. One is a hard coded way which will also clear the TCP connection. So basically that is not a good practice in environment or in a production environment, because if you make use of this command, it's gonna clear the TCP connection, the three-way handshake. So there will be a huge impact because it might take some time to rebuild, right? The second option here is soft reset. Okay, so what you're going to do is you're gonna clear the attribute now. So let's say clear IP BGP 8.8.8 and add the keyword soft. Okay, so let's see what is it saying. Okay, so what you do is just make use of the known network. So let's say from show IP route. So this is your network. Okay, so I'm gonna make it as 8.8.8.0. Okay, so it must be directly connected neighbor. Okay, so who is my neighbor here? So for C2, it's 10.1.3.2 soft. Okay, so it should be with respective to my neighbor. Let's see, let's hope for the best. Let's see if this has been taken or not. Okay, so you can see there are TCP connections still. So there's a TCP connection still, and there was no uh, break in the TCP session. Okay, so I'll also make sure this command is being placed for C1 as well. So show IP BGP, clear IP BGP. The neighbor here is 10.1.2.2 soft. Okay, so if that clear command doesn't take, then I will do the second command, the hard reset. Okay, that's this command. So this is a complete TCP initiation. So it will disconnect the TCP and it is gonna rebuild the TCP connection. Okay. If the soft doesn't work, then you don't have any option. You just have to manually do this. Okay. The attribute manipulation will not be automatically considered until you clear them, until you route refresh them. Okay. So they are in a building phase. Once the update packet comes, you will see all the prefixes. So let's see the neighborship. Okay, so they are coming up. Let me try to ping the destination. Okay, so it's reachable. Let's see the trace route. Okay, so you can see now it started taking up 13.2. So it started taking up this route now. Okay, 13.2 is nothing but this IP. 3.2, which is nothing but this IP. Okay, and you can see then the AS value getting added up, AS3. So basically it's taking up this. Okay, so let's see from show IBGP, which was earlier showing as two different path, right? So when you saw show IP BGP, you saw that this was the best path, but now you see that this has been considered. So basically I must expect this showing up as 150, which is making this as a best path when compared with the uh, 12.2. Okay, so let me do this show IP BGP, and yes, you can see this, the local preference has been changed, and I can see that this is being triggered as a best path, and on my routing table I must see 13.2. Okay, so that proves that whenever you are sending a packet out, you can change the behavior. If you want, let's say you have two ISP, ISP1 and ISP2. You want some of the networks to be sent towards ISP2 and then they take the path, right? And might be even in the interview question they ask you that there are a couple of networks and I do not want all of them to be taking up the primary path, because that will just lower, or that will just slower down my entire networks, right? So few of them I would prefer sending across on second link, and rest of 80% let me still take up the primary link, right? So this is how some of your questions are answered. Okay, so these are the attributes that's gonna help you to achieve those scenarios. Okay, so what does it prove? What does it prove with respective to local preference? You must also know the theoretical values. Okay, so it's for outbound connection. It's not limited to the local router, right? You configured on one router and the other router was automatically spanned, right? So it was basically got spanned across the autonomous system. Do you think local preference will be moving to the next autonomous system? No, it is within that autonomous system, but it will be across all the routers of that autonomous system. I mean to say, whatever local preference you configured, it's gonna be within this, it's not gonna move forward, but it's gonna be known across all of the routers of that autonomous system. Okay, so that's the behavior of local preference. Okay, it is removed on eBGP connection. So when a eBGP packet is sent, you will, your local preference, whatever manipulated values, that would be taken out. Okay, so you will see most of the time local preference. So if you see other local preference, they are by default having the default values. Okay, the 100 values. Okay, so that was regards to local preference, and the higher the preferred, and the same thing I can do it with the help of route map. Okay, so why do we use route map? So route map is used when you have multiple networks and you want to uh, permit some of them, or let's say you want to restrict some of them. Okay, so in such cases you need route map to define uh, the definitions. Route maps are nothing but access list. Okay, so route map, these are similar to access list, ACL. Why do we make use of access list? Either to permit or to deny, right? So you just want to permit A, B, and C, but you want to deny D, E, F, right? So basically you're making use of access list. This is more preferred in case of switches and firewalls. Okay, however, in case of routing, we make use of route map, which is more scalable. Okay, the definition or the meaning of, or the purpose are the same, that's to block or to permit, but yes, with the routing we make use of route map. Okay, so how do we configure the same configuration with the help of a route map? Okay, so what I'm going to do is I'm gonna show, I'm gonna first take out the value, or let's say I make use of route map on my second router, and let's uh, take the first path once again as a good path. Okay, so I mean to say, as of now I configured the basic configuration, this one. Okay, and I just manipulated the behavior. Okay, so this basic was configured here and I set 150. Okay, so let me make use of route map now, and let me configure. Okay, one second. Okay, I think I lost the pointer. So anyway, so what I'm going to do is I'm going to use route map on this. Okay, and I'll just make some 250, 300, so that my path is once again considered this. Okay. So let me go to C1. Let me go to router BGP1. But before that, before implementing, I must define route map. Okay. So let's say route map, and I can take any word. It's just a word. Okay. So let me say it's a local preference. Okay. What are you going to achieve out of this? So let's say route map local preference, and what are you going to achieve? So basically you can do a question mark, and you can see there are a lot of options. So for me, it's local preference. It should be more than 150 so that I bring my AT&T back. So let's go with 200. Okay. I have defined local preference, but I have not called it. So to call this, I will go back to router process, and I say neighbor 10.1.2.2, and I set the route map in some in a direction. Okay. So what is my word here? It's this, right? So let me take this, and on which direction are you applying? Now this is might be this is little confusing, but let me tell you, whenever you're making use of the directions in and out, okay, in case of the BGP route maps, so let's say I'm talking about outgoing traffic. Okay, so the traffic which is going across in this direction. So where is this hitting on C1? It's hitting on this in. And let's say this was out. Okay. So for an outgoing direction, this should be my route map that should I consider in. Okay. Now same thing when I am expecting the traffic, which is a incoming traffic, where would that incoming traffic hit first? It will hit on out interface. So my out map should mark on out. Okay. The same approach even goes with the firewall. When we deal with the ASA firewall or Palo Alto or whatever, the access list. Okay. So these firewalls have interfaces. So we call it as in interface and out. Out is something which is going towards internet. In is something where you have your all local server or LAN segment. Okay. When the access list hit on this interface, we designate with some word called as in, so that we know my access list is first hitting on this. Okay. And if I'm having incoming traffic, that the traffic is first hitting across on this interface, which is out. Okay. So this is in case of ACLs, access list. We need to define on which direction is your traffic flowing. Is it in and out or out and in? Okay. Same goes with the route map. We are talking about the direction. We are talking about packet direction. So in this case, in the case of local preference, it's something which is going out, right? So it's first hitting up the in interface of this, right? So I'm gonna consider in over here. So I'm gonna say I'm applying to incoming routes, the routes which is hitting on this. So I say incoming. Okay, so you can consider in this way. Yes, you can bring your own ideas so that you remember this, but I would relate this with the firewall. Okay, firewall has very similar concept. So I have applied this route map on a incoming direction. Okay, the incoming direction. So time to do clear IP BGP process, and let's also do here clear IP BGP process. And now let's see what is the direction. So it must be taking up AT&T because I have preferred local preference, but yes, with the help of route map. Let's ping. Okay, so they started pinging. Let's see the trace route. Okay, so you can see they're back to the normal form AT&T. Let's see from the numerical or the numbers, because that's matter for us, not just theoretical, right? So let's prove that. Why is it taking 12 network? So it's taking 12 network because of a higher local preference that we have set. Fine. So we did this with a route map. Okay, and route map is when let's say what let's say, okay, so let's say when I'm preferring this, okay, so I'm defining my route map associated with this neighbor. Okay, so it becomes easier for me. So route map, you can just consider it as a big bucket where you can apply multiple policies in the future on scenarios. Okay, so you can just take it as a group, otherwise a group where you can place policies later on. So as of now you just set one policy of 200 local preference. Might be in future you just need to change them, so you don't have to change across on all of them. So wherever you have just called, it's just matter of going to that group and just changing the values. So it's quite simple when you have grouping. Okay, so when we have these kind of route map. Also, the other use of route map, as I told you, is, let's say I had few groups of network, let's say 1.1.1.1, 2.2.2, or let's say all your non IT guys. Okay, you want this to be considered, this to be the best path. So you can make use of route map and the prefix list to achieve that. So I'll show you this in my next example as well, how you make use of this prefix to use this, and rest will by default will be taken up, whatever is your best path, right? So BGP is all about scalable, the way you want to scale and the way you want to bring a good cost to your environment or your network. Fine, that was regards to local preference. I have covered both of the steps. Uh, the few commands which will help you to analyze or troubleshoot or observe. Okay. Yeah. So this is the list which I was talking about. So let's assume that this let's assume by manipulating the local preference, this is considered, this is preferred as a best router. Okay, let's say this is being preferred. So what do you understand? So basically I'm preferring AT&T for my networks, all my networks, so all of them are going across in this direction. Now there are chances AT&T is also gonna advertise multiple other networks. So let's say AT&T had some other routers, or let's say there were other networks here. Let's say apart from 8.8.8, I also had 10.10.10, 20.20.20, which was not really important for me. But even by default, they are also getting preferred over on this route. Now that's something which will impact my uh, packets or impact my communication. I am only focusing on this server, not on other hundred of servers which is listed uh, across on the destination. They can prefer whatever is the best path, uh, as per uh, as per the scenarios, right? If this is a best path, then let's take it. But I don't want my main path to have all unwanted or unnecessary packet also. Now that can be achievable. Okay, I'm gonna put some prefix list here. Okay, I'm gonna say prefix list for this must be only allowed here, whereas others it's deny. Okay, I'm gonna deny all other servers. I don't care, if even if they don't reach or even if they take a secondary path, that's okay with me. But my main focus is on some, let's say these are some mission critical servers, which is very important for my production. And I always need this path, right? So in such scenarios, I can place some prefix list. Okay, I can bring up the concept of prefix list. So let's say when I go to C1, I say IP prefix list. What is the destination that you want? It's okay. What is the sequence number you wanna use? So let's say you are going with sequence 5. What are you gonna do with this important servers? You're gonna permit them, right? And what is the prefix and the prefix length? So it's 8.8.8 and let's say 32. Let's say only one server is very important, or if you want, you can give the complete network as well, doesn't matter. Okay, and then you just need to bring this under route map. So what is the route map that you are using? So let's see my route map. Okay, so that's why I said route map act as a bucket, okay, where you can place multiple policies later on. You don't have to manually go and add this at the end of neighbor command. So you have a route map with this word, just go and set up or call this. Okay, so I'm gonna go to the route map command. I'm gonna make use of this once again. Okay, I'm gonna say permit whatever, it's 10 or something. I'm gonna say match IP address prefix list. And what is the prefix list? So I have made use of some word here. So basically this is my word. Okay, I'm making use of 8.8.8. That could be word also, a string kind of thing, but I'm making use of a numbers to have a easy understanding, a clear understanding. Okay, so inside my route map, I said this is my prefix list which has to be allowed, and I also set the local preference, and I say local preference is 200. Fine, that is something what I had configured earlier. Okay, so you see this has been called here. I don't have to go to the BGP process. I don't have to add something, remove something. It's already been added and already the direction has been tagged. It's just that I went to that big bucket or big container and I just manipulating the uh, policies. I'm saying I want this to be added, I want this to be removed. I'm saying this is that value to be considered. Okay, it becomes very easier when you have uh, these object groups. Okay, in firewall also we have this concept, we call it as object groups, where you can group multiple policies on one object group, and this can be called on multiple interfaces or multiple packet flowing directions. It's more easier. Instead of 100 lines, you just reduce it to 10 lines or might be 5 lines. Okay, so that's called as grouping. Fine, so this was one last part in local preference. Okay, the same goes with all other attributes. Say for example AS path. Okay, so what I'm going to do is I'll just reload this so that I get a fresh copy of my router, and I'll show you AS path. I'm not going to save any configuration. I prefer reloading because instead of going deleting one line by one line, the reload will bring up the configuration that I want and I can just set it up. Okay, so basically while doing some labs at home or on my server, I prefer reloading once I've done the attribute and I want to try the next attribute, because I have option of deleting one by one, but that's again a personal preference. If you prefer that, you can go with that, but if you want to go with a reboot, so that's also fine. Okay, wait proved, local preference is proved. Now we are going to check AS path. Okay, AS path is when it's for incoming traffic. Okay, so incoming traffic will be seen from this point of view. Okay, so I'm still over here XYZ, and let's assume AT&T is having a very bad packet delivery, which is not good for me, and I just want to change the behavior. Okay, and this is the scenario when I cannot bring any changes on my network, strictly no changes. Okay, so in such cases, I can tell my ISP, and the ISP will prepend some dummy AS path so that this is not getting considered and this path gets considered. Okay, so I told you that that's what I said. It's depending upon your circumstances. Okay, your network circumstances. Sometimes you do not have rights on your own routers to change something, right? So in that case, you can request the ISP to change from their side. There are some circumstances when ISPs are not very what do you say responding nature, and you have to do the changes. So that case, you just have to go and manipulate on your self routers. So it depends on what uh, cases you're trying to change. Okay, so let's say in this case, AT&T is giving me slower packet delivery and I'm not happy with this. I tell my Vodafone or I tell AT&T that you are not going to give me something, so until then let me make use of this, and I don't have any rights to change anything on my router. So what AT&T is gonna do is they're gonna prepend some AS values. Okay, so as of now, you know, by default this path was getting considered, and you have 2, 4 and 5 AS values getting added up to the prefixes, and on this side you have 3, 4 and 5. So let's say I add some dummy values 4000 and 4000. They don't exist, they don't exist in the nature, but we are just prepending some values, the dummy values. By default, what should be the destination be thinking now? It will be thinking that why should I make use of a longer AS path? Why don't I make use of a lower AS path, right? So that's one criteria. If you remember, that's a criteria here to packet forwarding. Let me show you which one is that. Okay, so if you see here, the fourth number is about AS path length, and who wins the election? It's your shortest path that gets uh, elected, or that gets been preferred. Okay, so AS path shortest is preferred. So that is what AT&T is gonna do. They're gonna uh, add some dummy values or some dummy AS so that the second one automatically start getting preferred. Okay, okay, give me 1 second. Let me delete few of the previous recordings. So that's why I keep two recorders. So I have the second one with me. Okay. So anyway, okay. So where was I? I was on AS path, right? Okay. Well, so let me show you the config for AS path. Okay, and then I'll walk you through some points which we have already discussed, but no harm revising. Okay. So let me first ping the destination. I'm reachable. What is my path? So it should be back to 12 if I'm not wrong, right? So it's back to 12. Okay, the default behavior of lowest router ID. Fine. Now I don't want AT&T. Okay, I don't want AT&T because they are giving me a slower packet delivery. Let's prefer Vodafone. And at the same time, I don't have any chances of changing anything at my side. So I say AT&T, do whatever and just uh, just try to uh, just try yourself to be secondary, and so that I have someone else. Okay, so what I can do is I can show it on my P router, or on the P side. Okay, so if I go to the P router and I say router BGP1, okay, sorry, it's AS value 2, and yes, I first have to define router map. Okay, a route map. So I say route map. Let's give it as AS path prepend, some keyword. Okay, I say permit 10. I'm gonna set some values. Okay, so let's set AS path. So what am I going to prepend? So I'm gonna prepend some AS values. So let's set it as 4000 and 4000. Okay, you can set it more, doesn't harm. Okay, and now let's go to BGP process. And what is the neighbor that I'm gonna bring this effect? I'm gonna bring it on this. Okay, so who is this person? He is on 2.4.2. I say neighbor 10.2.4.2. Okay, what is the route map that I'm gonna use? Just add the keyword, and it's gonna ask me for in or out. Now that's interesting. Okay, so this is for incoming traffic. Okay, it's gonna hit the out interface first, so I'm gonna take out this time. Okay, fine. So let's clear the BGP process. So let's see from Google server now. How is it sending the packet to us, and on which direction is this going? Sorry, it is not 8.8. Instead, it will be the loopback of this interface. Okay, that I need to check. So that's this IP, which is over here. Okay, uh, fine. So let's give a ping. Well, it's reachable. Let's do trace route. It's taking 5.1.103. Okay, so it started taking up this path. Okay, let's see few more commands. Let's see show IP BGP, and you can see those prepending happening. Okay, so you can see 101. This is preferred, which is a Vodafone path. Okay, why? Because your AT&T has some prepending or AS prepending values. So basically this is gonna get excluded. Okay, because I prefer the shortest path to reach. I don't want my packet to travel through three more autonomous systems. So that's what my BGP is gonna think. BGP is gonna think, why should I pass it to three different autonomous systems? Let's go with the shorter path, and that's why the AS path come into picture over here. So there's one more attribute, very important attribute, and yes, I have mentioned it as CE1. It should be PE. What is the naming here? It's P1. Okay, so that's P1. That's the only change, and might be the IP address. Okay, fine. So show run command, and fine. That's about AS path. And what does it say? It's a fourth attribute. It's a well-known attribute. AS path are it's a mandatory attribute. Okay, ordered list of ASN. So you will see AS path values getting carry forwarded. Okay, so it will be carry forwarded AS to AS. So that's something which you need to remember. You will see multiple times, so the path becomes longer. It's a way to manipulate. You are influencing the inbound direction. Okay, the shortest path is preferred when compared with the longest path. And these are few commands, and these are the prefix. Sorry, the route map. You can also bring up the prefix and just tune accordingly. Okay, fine. What about MED? MED, I'm just gonna explain, and might be you guys can do it. Okay, so let me tell you what is MED. So MED is something which I don't think will be used regularly, because we don't see one router which is always connecting to two autonomous system. It's very rare scenarios we use such setups. Okay, normal setups are usually one router with one ISP, and we have the second router which has other ISP, and so on. Okay, but we don't have one router connecting both of the router, because we cannot depend on one single point of contact. If this goes down, then basically both the ISPs are going down, and there's no point of keeping secondary link, right? But yes, let's talk about from the med, which is changeable, which you can manipulate to bring the changes. Okay, if you see in this diagram, this is my enterprise XYZ, this is my ISP. Okay, and the traffic can come over on this direction or over on this direction, and that is what I'm trying to change the behavior. If the traffic is coming over here, I'll make use of the MED, and I'll prefer this route. Okay, so what is it? It's a sixth attribute. It's a non-transitive attribute. The lowest is preferred. It is exchanged between autonomous systems. So you will see your med will be exchanged between the two autonomous systems, but the same med will not be forwarded to the next autonomous system. Okay, you will not see this med over here, neither this is gonna forward them to the next AS. Okay, whereas in the case of AS, they were all being taken across, so you could see A to Z AS getting mapped with the prefixes, right? But in the case of med, it's just between this and this. Okay, so they are exchanged, but they're not passed along to other autonomous system. They are not going to be passed. Okay, so they are also influencing the incoming traffic, something which is also AS path going to do. This is the scenario I have just shown you with the help of a red line. You just need to place one link like this. Okay, something like this, and you should be good to practice. So take your time to practice. Okay, also you have the configuration, so you don't have to worry. I'm making use of the route map once again. As AS path also had out, MED also going to have out. You just set the metric. By default they will be 0. Okay, you will see the metric on eBGP to be 0. Okay, not only eBGP, for all the default routes, if until you manipulate, the metric will be shown as 0. Okay, as quickly you change to 50, now you will see the cost to be 50. So let me show you what is that. Okay, so if you see this column, right, so it says to be metric. So don't get confused with your dynamic protocol metric, the cost metric, because for BGP cost is not important. So in BGP, MED is recognized with this word metric. So if you see 0, that's a default behavior. Okay, as soon as you may increase to 50, now that path will be not preferred. So basically you're just changing the MED value to 50. So the lowest is preferred in case of MEDs. Okay, fine. So this ends the 4 important attributes which can be manipulated. But yes, these are not the only ones. Okay, so we have multiple attributes. If I show you the table, So if you see this, there are many more attributes, okay, which we may not have even discussed, like origin, atomic aggregate, aggregator, community, originator ID, cluster ID, right? So why we don't discuss this? Because these are something which is not a path decision maker. They are not influencing any kind of path manipulation or path selection. But then why do we use this? So you can just take it in this way. If you have to send some additional messages, right? If you want to send some additional messages, say for example some tagging, let's say you are trying to send some information about a uh, uh, how old are those routes, right? Those are not, those are something which is considered to be additional messages, right? So these additional messages are the other attributes, and they are not path selection attributes. Okay, for path selection attribute we have these 11. Okay, so these are gonna be path selection attribute. So few of them you can manipulate, you can change. Rest still remains the path selection, but you cannot change them. That's a theoretical topic. Apart from this, there are couple of more attributes which is used for your full functionality of the BGP. Okay, so let me tell you what are few things. So let's say in the case of originate, okay, which was not a part of was it a part of path selection? Let me just check this. Okay, the third factor, originate. Okay, so we have not discussed about originate, so let me tell what exactly is that. So originate is something which tells where the routes were originated, whether it was originated within the router or it was learned externally from a different autonomous system. Okay, if the route were learned locally, then you will see the next hop with this uh, representations. Okay, let me see if I have something similar to show you. Okay, you can see here on my Google server, which is having the loopback in this network, what is the next hop you see? So basically, it's gonna show me the originator. It's a locally originating route, right? Whereas rest of them, they were originated or they were learned from different autonomous system. So that's over here, and this is the third attribute. Okay, weight, local preference, originate, and let's say if originate is not going to help, then the next one comes is the AS path, which we did some labbing today. Okay, so it's a third attribute. Prefer the path that local router originated. In the BGP table, local router is set with this next hop. Routes with set to this is considered as local route. Yes, that's also true. When you see a weight with 32768, so that's when you have IBGP. Okay, all your IBGP learned routes will have this, but yes, it doesn't matter that they were originally originated from the local router or might be one of the IBGP router. Okay, but they are just an indication to prove that these are within or these are some local routes. Okay, but the exact information you can see from this. So you can see these are locally originated. Okay, so this is the loop back of this router and this is the physical IP of that router. So you can see this. At the same time, you can see the weight is 32768. That's just a cross combination possibilities. Okay, the main thing that you need to see is uh, the way how it's originating. So this will help you. So BGP router will prefer routes that is installed in the BGP itself. Okay, instead of something coming from a different AS, it will prefer its own originate. Okay, regarding the fifth criteria, the fifth path selection. I'll just take the snipping of this instead of scrolling every time. Okay. So what is the fifth one? Origin code. Okay. So you might be knowing there are different flavors of BGP. One is IBGP, eBGP. Okay. Now you will also read some prefixes apart from these two. They are most probably the redistributed networks. So what are redistributed networks? The network which are being injected inside BGP process. Okay. So let's say in the case of IBGP or eBGP, if I'm injecting the OSPF routes, or if I'm injecting the EIGRP route or a static route, right? So the whole terminology or the whole technology can also be called as redistribution. Okay. So basically I'm injecting a different routing protocol within BGP. Now those prefixes will be having this kind of symbol. Okay. So for IBGP, you are gonna see I. Okay, so let me show you over here. So if you see this, that means it's IBGP learned routes. Okay. Do you have anything else here? Okay, so this is origin code. Okay, so you can see over here, this is origin code. So basically, the one which is over here was truncated over here towards this. So you will see I for IBGP, you will see E for EGP, you will see incomplete when you have some redistribution. Okay. So this is IGP, EGP and incomplete. That's when you have the question mark. Okay. And what is the best one over here? So it's a well-known mandatory. Once again, it's a well-known mandatory attribute, and IGPs are preferred and EGPs are preferred to incomplete. So when you have three things, so the first preferable would be this, second would be the EGP, and the third one would be this when you do not have any other way to reach. The seventh attribute here is this, eBGP over IBGP. This is clearly because of the AD values. Okay, for eBGP you have AD20 and for IBGP you have AD200. So as we know, the lower the AD value is more preferable. And you know what is IBGP and eBGP. Okay, so I'm not gonna repeat the same thing. Shortest IGP path to BGP next hop. Okay, that's the eighth path selection criteria. Shortest IGP, interior gateway protocol, to BGP. So let's see what does it say. So it says that prefers the path the received first, or sorry, okay, this is the one, right? It prefers the path within the AS with the lowest IGP metric to the BGP next hop. So that's one reason why I took EIGRP from this lab, because while checking the path manipulation attribute, I was just seeing that my BGP was considering EIGRP route to take back from this path. Okay, so that's one reason why I took the dynamic routing protocol, because I just want to keep it very simple with excluding the other protocol, just focusing on the BGP path manipulation. But you will see that if you bring EIGRP or OSPF, your BGP path selection will be little different. Okay, so now it's very simple, it's very straightforward, either this path or this path. But let's say this path was primary and this was secondary. Now what this router is gonna do is, instead of making use of this EGP path, it's gonna send back to this. And am I audible or I lost you guys? Am I audible or I lost you guys? So do you guys don't hear me? No voice? Oh, okay, fine. Okay. So I was talking about this lab. So let's say when I have the primary path, okay, over on eBGP, and for some reason I just changed the attribute so that I see that my path must take this, right? But what happens is, when I have a dynamic routing protocol, the second router, the C2 router, it has two options now: either to make use of EIGRP and send back and take this path, or to take the eBGP path. So what happens as per this statement is, it's gonna prefer the IGP path. That's true. Okay, it's gonna take this path and then it's gonna take this. So I will be not able to show you any attribute in that scenario, right? So that's something, a default behavior. That's one reason why I took down EIGRP from this scenarios, because I don't want other things coming towards this lab. I want this to be with regards to attributes only. Okay, if you keep BGP, you will not see this glitch. But if you keep some EIGRP or OSPF, you will see your second best path will now consider that, or it will send back on that path and it will come over to the destination. Okay, the eBGP will not be getting considered. So that's something which I wanted to share over to this. Okay, so the prefer the path within the AS with the lowest IGP metric, where irrespective of eBGP. Okay, regards to the shortest path, so prefer the path that was received first, or the oldest path, whichever is the oldest path. How do you see the uptime or all those things? It's if I do see this, so I see there are some timers, right? So this is older, or this has been there for like last one hour or close to one and a half hours. Okay, so that's how you decide which is older and which is a newer line. And yes, the last few things like router ID and neighbor IP address is something which you guys know. So the lowest one is preferred, and without these two things, the BGP process will never start. Okay, so BGP needs router ID, and the router ID is something which will be sent inside the hello packet along with the other parameters like AS values and timers, and then they form the neighborship, which we have all gone through with so many classes, right? So these are two things which we require. Now that ends your path selection. We have discussed all of them. Okay, the next two attribute are the one which is not part of these. Okay, they are not part of path selection, but yes, they are still attributes. As I told you, some attributes which are used to carry the extra informations, right? So I'm talking about this now. I'm talking about few attributes from this, not all, because some are repetitive. Okay, some in the sense like atomic aggregate, aggregator, community, cluster ID. These are one which we have not discussed. Others are already discussed, right? They're the path selection attribute. Let me quickly also wind up on that, and we are good with the class. Okay, or we are good with the path attributes or the BGP attributes, the main important topic. So what is atomic aggregate? So this is something when you're selecting a route point of view, or okay, let's say when you want uh let's let's say when you have two path, this and this, and you know that this was being preferred. Now let's say there was some extra let's say there was some specific reason that this router has selected up this. Okay, for some specific reason it selected this, not this. Now how is that specific reason going to get carried across? Because when it's not a packet flow just within a single autonomous system, so you see there are multiple autonomous system involving, right? So what is that specific thing is gonna be carried? So that's this attribute. Okay, so this is optional kind of attribute which can be present, which cannot be present. It just depends on the scenarios. If on a specific or a less, or let's say when a less the least specific route was preferred, now that information will be added to the prefix or to the prefix, right? So saying this is the special criteria why I have uh, preferred the second route, not the best one. So that is the attribute atomic aggregate. In short form, that is the one, and this is the all the line by line which you guys can read. So it's a well known attribute, and aggregator is optional, or it's a transitive attribute. Okay, so there are two things: atomic aggregate and aggregator. So let me just quickly read out. So when a least specific route is preferred, okay, over on the more specific route, it must attach the atomic aggregate attribute to this least preferred, okay, while propagating the route. The atomic aggregate attribute lets the BGP peer know that BGP speaker used an aggregated router. For it's just to inform the next peer that there is a special reason for considering the second path. Okay, and that and so on, to pass it or to pass it or move on to the next person. So it's something which is uh, used when this feature is being pulled up. It's not a decision maker. It's one of the attribute. Whenever you see that a least specific route is being taken up, you will see the atomic aggregate getting added up to that prefix, and your NLRI is gonna take responsibility from AS to AS to carry the second path, and this is gonna carry that information that I chose this path because of so and so. Okay, it's all BGP software algorithms. It's something which we cannot change it. So that's why I say they are not a changeable factor. It's a software which will decide, and it will do what is required. The BGP communities. Okay, it's again something like a extra information, and it's specially used for traffic engineering or routing policies. Okay, so it's when it's a optional transitive, and it will be propagated from AS to AS. So basically BGP communities come with 32-bit and 16-bit. 216-bit, which is like written in this format. If you remember, we had gone through the 4-byte AS numbers, where we saw AS dot and dot plus and the plain values, right? So similar thing. And what exactly community is going to carry? It's going to carry traffic engineering or policies, okay, dynamic routing policies. So it's a bit of extra information that will be added to the prefix, which is advertised to the BGP neighbors. Okay, so they are gonna provide additional capabilities for tagging routes or modifying BGP routing policies towards upstream or downstream. It can be any side. Okay, the BGP prefix, it can be over on the downstream, or it's going up towards upstream, towards the destination. So these are few attributes which I just thought should be important from the interview point of view. So let me see quickly what else do you have in the attributes. Okay, so the ENCORE paper says about path selection and neighbor relation. That's okay, we have done that. And what about the NRC paper? Okay. So this is NRC where we have troubleshooted internal, external. IP4 is covered. Next hop, multi-hop, 4-byte, AS, private, route refresh, synchronization, operation, peer group, state, timers, fine. Path preference, attribute, and best path we discussed today thoroughly. Yes, so my next class would be on route reflector. And yeah, policy is something which we discussed today, okay, inbound and this is filtering. This is about filtering. Path manipulation is something which we discussed. So this we will take up in the next class along with this one. I'll talk about synchronization, which is a simple topic, not much. And yeah, so basically, I guess one more class we need for BGP. Okay, so that ends your BGP from CCNP point of view. So for CCI, you have few more added up topics, but yes, in CCNP itself, we covered a lot of things. Fine. So let me see if you guys have any Q&A. So do you guys have voice issues still? No voice? Okay. 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 Let me check your Q&A. So if you have, you can also let me know. Are you creating the route map just for IBGP within the AS? Uh, Route map is local, one thing. Okay, it's a locally significant. And second thing is when you have multiple networks, as I told, let's say I have ISP1 and ISP2, and you want to club like two or three networks to take the ISP1, and similar way you want the other prefixes to take ISP2. Okay, so in such scenarios, we can make use of route map. We can set the policies because I don't have to Otherwise I would do it individually. I have to go to the neighbor statement and add the values. But with the help of route map, it's more simpler. Okay, so it's making my job easy and also scalable. In future, I don't have to change anything within this line. Let me tell you what is that. So the main configuration for BGP was this, right? So I don't have to deal with changing anything across this. So I just go to the prefix or the route map folder and I just set the policies or I remove the policy. Is it not possible to do the AS path depending on the CE router? So let me tell you, AS path is also used for inbound and outbound selections. Okay, so when you have AS path, you can also make it used for inbound as well as outbound. So that's one thing. Second thing, to answer your question, yes, I can do it on C routers. But if you remember, I just got another situation or another scenario where I said I don't have any rights to do changes on my router. So that is why I said I'm gonna change AS prepending on the AT&T side, on the service provider side. So that was my intention and that was my scenario for that point. But yes, I can also change over here. As you see my PDF, I actually have changed on this. But during the class, I just told that I just brought another scenario where I said I don't have any rights to change anything across my side. So I have to tell the ISP to do the required changes. So in that case, uh, that's the reason I did it on the AT&T side. Yeah, actually, uh, there's some issue with the one of other link because you guys got some black screen initially. So I'm not sure why was that. So I'm connected to the secondary link. So might be that's why I'm having some voice issues. So are we good with the class today? Do you guys enjoyed the BGP class sessions going on? Anything which you want me to get in the next class, or something that you want me to repeat, or something that you want me to give you a practice set, or something like, do you want some BGP lab for this weekend? You want to attempt some BGP lab, so I can also give them. Okay, so just keep it posted. And yes, so let's meet up in the next class, and I'll just give you all the configurations and all the class notes as usual way on the web portal. Okay. Yes, I can give you that. Okay. Fine, guys. So let's meet up in the next class. And till then, have a nice day. Stay safe. Thank you, everyone.